right, we're going to look at how we can find a second derivative with implicit differentiation, because we're asked to find second derivative here. So let's go through first. Anytime you find second derivative, you got to find first derivative to start with. So first term there is going to be 4x cubed if we take the derivative. Next one's going to be 4y cubed, but that's y, so we got to include the derivative, dy dx. Derivative 16 is 0 because it's a constant. Now let's solve. We'll minus that 4x cubed to the other side. And then we'll divide by 4y cubed. And then last thing we can do here, those 4's cancel, so we can make it a little more simplified. First derivative here ends up being negative x cubed over y cubed. So that's our first derivative. We could also write it as y prime. Our second derivative, we got to take derivative of a derivative now. So if we take the derivative of that left side, it's just going to be either y prime if you want to use this notation. If you're using the Leibniz notation, it would be written like this. Both say second derivative. Now what's the derivative of this right side? So here we got a fraction. We're going to have to use quotient rule. So we got low d high, derivative of the top would be negative 3x squared, minus high d low, derivative of the bottom would be 3y squared, but it also needs the derivative dy dx, because that was finding derivative of y, all over our low squared. All right, let's see if we can simplify that down. There's some terms we can multiply on this first one. So I'm going to make that negative 3x squared y cubed. On that next one, we got minus and negative, so that's going to turn into plus. So we got plus, and multiplying that, we got 3x cubed y squared dy dx. And then on the bottom, power to power, we multiply y to the 6. So that's our second derivative, but most times what they're going to ask you on these is to write your second derivative just in terms of x and y, meaning we don't want our first derivative being part of our second derivative. So what you do then to remedy that, or to get rid of that, we know what the first derivative is. So you're going to take that, substitute it in for the derivative here, and then our second derivative only has x and y as part of it. So if we substitute that in now, we get this. And now it only depends on x and y. From here, I don't know how far they're going to ask you to simplify that. Usually we try not to leave things as fractions over fractions, so we could multiply by 1 over y to the 6 to both top and bottom here to write our most simplified answer. So it'd be something like if we're going to end up distributing that to both. So it'd be negative 3x squared. You got y cubed over y to the 6, so that would leave y cubed in the denominator. This next term, I'm going to multiply. It's going to end up being negative here, so minus. We got, it's going to have a 3. X cubed times x cubed is going to be x to the 6. And then we got a y squared here, and then we got y to the 9th on bottom, so that's going to be over y to the 7th. So that looks like our simplified second derivative there. All right, I want you to attempt this one again. This is notation for second derivative. Pause it, see, get as far as you can. And then hit play and kind of see where you're at with that. All right, let's check and see where you're at. This one, you're going to need to do product rule when doing implicit differentiation here. So here's my product rule. Notice I did put it in parentheses because we're subtracting it there. And then I distributed that negative to both. And then keep solving. You should end up with this first derivative. Now we got to go for second derivative. So derivative of the left side is our second derivative, which we're after. Derivative of the right side, we're going to have to do quotient rule again. So you got low d high with derivative of y is just dy dx minus high d low. Derivative of that's going to be 2 dy dx minus 1 all over our low function squared. To simplify that now, we're going to have to distribute this negative y here to both. So we get 2y minus x. It'd be minus 2y dy dx, and then end up being plus y there. All right, now we got to get rid of those dy dx's. So we're going to take our first derivative, substitute it in for both of these, so that we don't have our first derivative as part of our second derivative. Doing that. This. So that's what we get. One nice thing I see that would happen is those would cancel out. So then we're, after that, we'd only have a y left there. So we can add that y with our other y over there. So we'd have 2y minus 2y times at this point, again, I don't know how far they're going to want you to simplify this. This is pretty good. It probably shouldn't leave fraction over fraction again. So we could try to simplify that by multiplying by reciprocal and doing some stuff like that. But that's the main point, is that you're looking to substitute back in once you have that first derivative. Here these cancel. We're going to have to make sure, since we got two terms, to distribute that. So we'd have 2y over 2y minus x squared minus, and I'm going to multiply these two things together. So it'd be 2y squared. Here we already have a 2y minus x in the denominator, so this one would be over 2y minus x cubed. And again, I don't know how far. That's pretty simplified right there. Would be the second derivative.